Hello dear students. So in today's session I am going to teach you how to find equivalent spring and then how to address a very complex category of problem in SHM where we are trying to find angular frequency of an oscillating system involving multiple springs and one block. So what are the kind of questions that I am talking about? Have a look at this. Okay, now normally this is not a very difficult question, but I've seen students struggling with this question, often taking about 4 to 5 minutes to solve this question, and then also many of the students commit error here. So we'll try to attack these questions and I'll tell you a way in which you will not only get faster answers, quicker answers, but you will also get correct answers every time you do such questions. So what are the key points to keep in mind? So what I'm going to teach you is applicable for situations in which there is only one moving mass. Okay, so keep in mind that only one moving mass is there. Okay, and apart from there it is only springs. Okay, so that is one thing that you have to keep in mind. Now another aspect that you need to remember is that we write force exerted by a spring as kx, okay, where k is the spring constant and x is the deformation. Now the same this is how we write force and elongation. We write energy stored in a spring. How do we write energy stored in a spring? We write it as half kx square. Now this is the most popular formula that students generally recall whenever we talk about the energy stored in a spring, but take note of it that this can also be written as k square x square by 2k, and therefore it will become f square by 2k. That is another way to write, and there is one more way to write. We can write kx into x, so that will become force into x by 2. Okay, so these are the other variations, other versions of the same formula, and sometimes any particular one version may prove to be more useful as compared to the other version. So we need to have this in our mind that there are other versions to use as well. Okay, now when it comes to this question, or when it comes to questions like this, we want to find out the omega of this system. So what to do? Okay, so my plan is to replace this system with the most common system that we know. Okay, so what I'm going to do, we are aware that if there is a vertical system, this is true even for horizontal system, okay, with spring constant k, then for this system omega is given as root of k by m. Okay, so this is something that we already know. My intention is to convert this arrangement into this arrangement. Okay, in other words, the arrangement that was given to me, let me redraw it here. The arrangement that was given to me, that was this. There is a spring, then there is a pulley. Pulley is massless. Keep in mind that we only have one mass. So the pulley is massless, the pulley is light. Okay, so this is the arrangement. I want to compare these two systems. I want to say that this is equivalent to this, and I want to discover that what would be the equivalent spring constant that can allow me to assume that this and this are equivalent. Okay, so how will I begin, or what can I think? What can I start thinking? If these two systems are equivalent, the block should never know that. For the block, every experience should remain the same. In other words, at any point in time, if the block is experiencing some force which we can name as T, then even this system should experience, even that block should experience the same force T at the same time. So at any point in time, the force on the two blocks should be same if they are identical. Okay, and apart from that, whatever energy is stored in this arrangement, whatever spring energy is there in this arrangement, the same energy should be there in this arrangement as well. Okay, let's see. If the force here is T, we know that the force in this string is T, the force in this string is T, the spring is massless, the pulley is massless, and therefore the force here should be 2T, which basically means that this spring is exerting a force of 2T. Now, if I'm trying to write energy of this spring, I would be writing it as force square by 2k, where k is the spring constant of this. Now this should be same as the energy stored in this spring. So for that spring, energy would be written as t square by 2k equivalent, and see this, we are done. T square gets cancelled, 2 gets cancelled. So we are left with 4 by k is equals to 1 by k equivalent, or in other words, k equivalent is equals to k by 4. Okay, so that is what we get here, and now we can very easily write omega of this system. So omega should be, okay, omega we would have written k equivalent by m. Okay, so here it will become K by 4 by M, and that is actually the right answer. That is the angular frequency of this oscillating system. Let's review what we did here and let's practice this for other questions. So what we did was that I drew a equivalent system. Then I argued that on both the figure the block should experience the same force. Then I wrote the energy of this system using in terms of that force that the block is experiencing. I wrote the energy of this system, the potential energy of this system in terms of the same force. I equated the two, that gave me the relationship. Now this is something that we will keep on repeating in various situations. You see here the situation is a little bit more complex now. We have two springs, K1 and K2 are the spring constant, but our approach will remain the same. I will draw a block, I will draw an equivalent system. So the block of mass M is connected to one spring only and the spring constant is K equivalent. The pulley is massless. Okay, if I assume that T force is acting here, okay, then I will assume that the same T force is acting here. Okay, the same T force is acting here. Now if we have T force here, it will be T here. Is it visible? I'll change the color because of the white background. So this is T, okay, this is T, this will be T, which means that the force in this spring is T and the force in this spring is 2T. So when I see that system and I write the energy, energy stored in spring 1 will be written as 2T square by 2 of K1. Okay, so that is the energy stored in first spring. Now the energy stored in second spring, how will we write that? That will be written as T square by 2K2. Okay, and that should be equal to the energy stored in the equivalent spring. And how will we write that? That will be equal to T square, because the force here is also T square divided by 2 into K equivalent. Now you're done. Rest is mathematics, and that too very simple mathematics. 2 gets cancelled, the T square gets cancelled. So we are left with 4 by K1 plus 4 by K1 plus 1 by K2 is equals to 1 upon K equivalent. You can figure out the value of K equivalent from here, and then very easily you can write omega. For example, K equivalent I will write as K1 K2 divided by 4 K2 plus K1. Okay, and therefore omega would be root of K equivalent, that is K1 K2 upon 4 K2 plus K1. Okay, and into M. Got it, everyone? Okay, so that would be the answer. So I hope you got the gist, and it does look like a very simple approach, right? We can try more questions. So here again, the complexity level will go on increasing gradually. Okay, so here again, I want to find out the omega of this system. We have a single mass. This is a fixed place. This is fixed. We have a single mass. We have two light pulleys. We have two springs, and we have a string. Okay, so this is a block. Okay, and we will assume an equivalent system like this. Okay, then if I'm writing the force here as T, if this force is T, then this force should also be T. Make it a habit to write the same force at the two blocks simultaneously. Then this is T, this is T. So the force here will become 2T because the pulley is light. Now this is T, this is T. The force here is again 2T. It's very simple now. You see, I'll do it directly. So 2T square by 2 times of K2, that is the energy of this spring. Okay, plus 2T square divided by 2 times of K1 is equals to T square by 2 into K equivalent. So this will become what? See, this 2 and this 2 gets cancelled. T square gets cancelled. So 4 by K2 plus 4 by K1 is equals to 1 upon K equivalent. I'm leaving it here. I'm pretty sure that you guys can finish the question from here. You can calculate the value of K equivalent, and then you can find out the value of omega. All right, let's try the next question, guys. Let's try the next question. Okay, so here again, conceptually it is still the same. This place is fixed. We have a single mass. Okay, let's just do it. Or do you want to do it directly now? I think you've practiced enough. Let's do it directly. If you assume the force here as T, then the force here will be 2T. Here also it will be 2T. We can clearly see that. Okay, here also it will be 2T, and here also it will be 2T. Okay, from the previous question, it is pretty much evident, and therefore, I will write 2T square by 2K1. Okay, 2T square by 2K2, then 2T square by 2K3, and then 2T square by 2K4 is equals to T square by 2K equivalent, and that's it. That will give you the answer. 2 gets cancelled everywhere, t square gets cancelled everywhere. So we get 4 by k1 plus 4 by k2 plus 4 by k3 plus 4 by k4 is equals to 1 upon k equivalent. Alright, so that would be our answer. Got it, everyone? Okay, moving to the next question. This question, do it carefully, guys. Like, don't get overconfident. Okay, because this question is a bit different from all the question that we did before. A bit different. Not too much different, but a bit different. A slight amount. Okay, where is the difference? So we'll assume T force here. We'll assume T force here. And here the force will be T by 2 and T by 2. So this spring will be exerting a force of T by 2. Okay, so we will write T by 2 square by 2K1. There is no other spring. There is only one spring. So this will be equal to T square by 2K equivalent. Or in other words, this 2 gets cancelled, T gets cancelled. So 1 upon 4K1 is equals to 1 upon K equivalent, or K equivalent equal to 4K1. Okay. So you see, guys, if you try these questions by other methods, you will end up spending a lot of time. But now the question seems very, very easy. Again, you will assume T force here. This will again become T2. This will again become T2. Are you seeing that? Like, should I write directly now? Square of this will bring a 4 in the denominator and K1. Okay. Square of this will also bring a 4 in the denominator. Okay. And then we will have. So see, if you have practiced enough, you acquire the ability to write things directly as well. Okay, you acquire the ability to write. I hope you understood that. If not, follow the regular procedure and do it. This one is a little bit more tricky as compared to all the previous ones that we did. Again, nothing will seem too much tricky now as far as this category of problem is concerned. If you have practiced this, then you are very good. Like now you are very good positioned to solve these questions. So this is T by 2. Okay, this is T by 2, and then if you notice, this will become T by 4, and even this will become T by 4. So there are 3 springs. We will write energy stored in all 3. So K1, it's T by 4. So T by 4 square by 2K1. Okay, next spring T2, again T by 4 is the force. So T by 4 square by 2K2. Then the third spring, the force is T by 2. So it will become T by 2 square by 2K3, and this should be equal to, the force on the block was T, therefore it should be equal to T square by 2K equivalent. Okay, now what do we lose? We lose 2's. We lose this 2. Okay, the T's will be gone, so we will be left with 1 upon 16K1 plus 1 upon 16K2 plus 1 upon 4K3 is equals to 1 upon K equivalent. Rest you can simplify yourself. You can find out the value of K equivalent, and therefore you can write down the omega of this system. Okay, so you see we have become pretty fast. Okay, this is a very tricky, like this is probably again it involves something that you have not seen in any of the previous problem. Let's see what it is. Okay, so we start by writing the force here as T. Okay, so this spring is also exerting a T force. This will also be a T force, T. So here also we have T force. Okay, here we have T force, which means that the force here is 2T. The force here is 2T. Okay, so if I start writing the energy for in the first spring, I will write T square by 2K1. In the second spring, I will again write T square by 2K2. Okay, for the third spring, I will write, that is also T. That is also T. So T square by 2K3. Okay, but now here is the catch. You know, by now you must have developed a practice of writing this as T square by 2K equivalent, but don't write that. What is the force on the block this time? What is the force on the block? It is not T. Notice carefully. It is 3T. 2T plus T. It is 3T. So this time you have to be careful regarding that. It should be 3T square by 2K equivalent, and that's it. Now only math is remaining, so you can finish the math yourself. So this will be gone, this will be gone, this will be gone, this will be gone, T's will be gone. So 1 upon K1 plus 1 upon K2 plus 1 upon K3 is equals to 9 upon K equivalent. So that would be the answer to this case. Got it, everyone? Okay. And finally, this case, the last case for today, but it's again a good one. This rod is a massless rod. Remember, I told you that mass will be present only at one place. So only the block has mass. This is a massless rod. okay, and it is hinged at this bottom. There are two springs connected here. So how do we solve this? So this time I will say that, okay, let me assume an equivalent arrangement like this. Okay, let me assume an equivalent arrangement like this. Now, if the force here is T, okay, let the force here be T. Okay, so this force will be T. Okay, and this force will be something different. Let us call as T prime. So one of the challenge for us is to find out the value of one of the challenge is to find out the value of T prime. How do we do that? This is a massless rod. So on a massless entity, net force and net torque should always be zero. So what I'm going to do, I'm going to write net torque about this and I'm going to equate it with zero. Writing net torque about this will give me the advantage of getting rid of these two, because these two will not develop any torque about this point. Okay, so I will start by writing that T prime into this distance, which is C into C, should be equal to T times of this entire distance, which is B plus C. So we have got the relationship between T prime and T, or we can write T prime in terms of T when needed. Now the energy stored in this spring, that would be written as T square by 2K2, okay, plus the energy stored in that spring will be written as T prime square. Let me write it. So T prime square by 2K1, and that should be equal to T square by 2K equivalent. Now T prime can be replaced from here. So we'll do the math. Okay, so what will happen? This two will be gone, and we will be left with t square by 2k2. I think 2 was gone. T square by k2 plus, let me go back. So t square by k2, t prime square by k1. T prime square will become, t square b plus c by c square by k1 is equals to t square by ke. Now t square gets cancelled. T square is present in all the terms now, so we can cancel t square. Okay, and we get 1 upon k2 plus b plus c square by c square k1 is equals to 1 upon k equivalent. So from here you can get the value of k equivalent, and therefore you will get the value of omega as well. All right, students. So I hope you got the point. I hope you got how this category of question can be solved very quickly and with minimal mistakes. If you enjoyed this, if you thought that, yeah, you have gained something out of it, please do like the session, do put some comments there and share it with your friends so that they can also learn from the same. I'll see you in next session, guys. Take care. Bye-bye.